Let's see, we gotta go here and find our, let's see, this is example problem 5.2. Oh, let's see, where is it? That's it right there. So we're looking at this bad boy right here. And we're trying to figure out now what they're going to ask you for on this one. It says determine the forces acting in members BD, CD, and CE. So BD, find my cursor here. BD, CD, and CE, right? Yep. So they're looking at these right here. Those three members. What's going to be critical here is you have to cut through all three of those members. Okay? Can't cut through four. You don't want to cut through. You're cutting through all three of these members. Okay? And you can't really do like a diagonal thing. So your section is cutting through like that. All right? So then what we're going to do is we have to decide which side do we want to look at. Well, you might guess that you would always look at the side that has the least amount going on. That would be my guess. Okay? Because you don't want all those other ones to have to deal with. What you're doing is you're gonna isolate this side over here when you do a cut through that section. Okay? And we're going to analyze that. Now the first thing you have to do is you have to go in and figure out what your reactions are at A and J, just like we always do. We have to know those first because that's an input, isn't it? And especially the AY and the AX are going to be inputs on whatever we're looking at over on the left-hand side. So we have to know those. We don't know them yet. So we go in and look at those, and you can see it. See what's in my little circle here? Those are the inputs we're going to have to know. We have to know this 1,600 pounds. We have to know the reaction at A and the X and the reaction at A and the Y. That's all we have to deal with at this point to find out what's going on there. Now, that will only tell us what's going on at BD, CD, and CE. We're not concerned with anything else. We're just concerned with what's going on there at this point. If we wanted to be DF, DG, and EG, we'd have to take a section from there and go the other way, wouldn't we? So what we would do is we draw our free body diagram first, and we know we've got AY going up. We think we might have an AX going to the right. We don't know, but it is pinned there, so we'll have to prove it. And then we think that J is going up, JY. We don't have a JX because it's on a roller. So we do our sum of the forces in the X, excuse me, equals 0. AX is all we've got in it, based on the inputs. So AX is 0. Sum of the forces into Y. We've got I put that, I haven't made that an AX down there. Nobody said a word.
You're gonna let it go.
Don't let it go. I get it wrong on the test. AY is going up, minus 1,600. Nobody ever lets it go when an instructor makes a mistake. Minus 4,000, don't give me that crap. Pounds, minus 2,400 pounds, plus JY. Too many unknowns. Sum the moment at A, 1,600 pounds, that's negative, right? It's making it go counter or clockwise. 1,600 times 4 bays at 12 feet, so that's 12 feet, minus 4,000 times 24, minus 2,400 times 36, plus JY times 48. That's it, right? JY stays where it's at, everything else goes the other side and becomes positive. So what is JY? I'm going to cheat. Maybe. 3,800? Is that what you said? Should be J's in the vertical. 40. How about 4,200?
Yeah, I got 4,200.
Yeah, that's what the book says.
Oh, yeah, got
4,200 pounds, right? Yeah, pounds up, right? Put that over here, 4,200. AY stays where it's at, everything else switches to the other side. So we got 5,600 plus 24, that'll be about 8. Minus 4,200, what's that, 3,800? I hope. Pounds up, right? Is that what it came out to? Thank goodness. Who needs a stinking calculator? If I can do that, you can do that, because I'm a dummy. So now what we do is we draw a free body diagram of what's in that circle. So we've got BD. Thank goodness it's just horizontal. We've got AB. Let's get some more paper here. We've got, to cheat and look at the book, we've got BC going straight down, right? We've got AC, so we'll call this BC. And actually, we really wouldn't have to label those. AC. Got this one going out this way. And actually, my BC, I'm going to have to erase that. Because we've got a force member right here, don't we? That's actually CD. And this is CE. We're dealing with BD, CD, and CE. That's all we're concerned with, isn't it? So I'm just going to leave this one go for now. Okay. So now we have to go in there and figure out what's going on. Oh, let's see. We're not done yet, are we? What was that, AY? 38? 100 pounds.
And you have 1,600 pounds coming down on B.
Okay. At B, we got this right here.
Why are we not looking at AC?
Because all it asks us for is BD, CD, and CE. Okay, and yeah, the distance from here to here is 12 feet. The distance from here to here is how much? 9 feet. That'll make a difference, won't it? Why does that make a difference? We have to know that angle right there, don't we? Right? So, what's that angle? Is that the 53? The arctangent of 9 divided by 12, right?
Yeah, the book just lets us know it's a 3/4
Right. 36.9. Where's my cursor? Come on. 36.9 degrees. Now we know everything except for what's going on, compression and tension. Well, let's see. What is going on? You get this pushing down, this pushing back up, but this pushing down normally on that truss, what did it say? The top chord was probably going to be in what? Compression? Get things, but that's a crapshoot. But look, we got 1600 here, 3800 here. More than likely, this one's pushing back up, isn't it? Or, excuse me, it's pulling down. Duh. 1600 can't overreact on that, can it? So it's probably going to be in compression. Pushing down. This one's going to be in tension. I don't know. I'm just guessing. I haven't looked ahead. Just guessing, so it doesn't matter. So what do I do next? Sum the forces in the X equals 0. What do I have? I got negative BD minus CD cosine of 36.9 plus CE. Holy cow. Way too many unknowns, huh? Sum the forces into Y. Minus 1600 plus 3800 minus CD sine of 36.9. That's it, right? CD goes to the other side of the equation. 3800 minus 1600, what's that, about 22 divided by sine of 36.9? What's it come out to? Anybody do it? Isn't that right? 3800
400.
minus 1600, 2200 divided by the 3664. Yeah, let's just make it 3664 pounds. It came out a positive value, so it was in compression. So we can put CD right there. Let's see. That was 3664. Uh-oh. And we're out of time. We still got two unknowns. Now what do? Panic sets in, right? But did you not at one point tell me some distances? And we put them on there, didn't we?
Yeah.
Could we not do a moment somewhere to figure out what one is? And where would you take that moment? I'm asking.
That's point A.
The last thing for today.
Remember the point
If you keep guessing, eventually you'll get there, right? Either you'll get there or everybody will walk out. This is point C right here, right?
A? Yep.
Take it at point C and you get rid of this and this automatically, don't you? And the 1600. So if you did a moment at C, you could go negative BD, oh, excuse me, that's positive, isn't it? Times 9 feet. It's making this thing go counterclockwise relative to C, right? So it's a positive. BD times 9 feet minus 3,800 times 12 feet. You'd be able to solve for BD now, wouldn't you? Then you could go back up here and plug it in and you'd have CE. If it comes out a negative value, then you guessed the wrong thing for CE. But I'm guessing it'll be fine. I'm not going to finish that at this point. Do this for me for practice. I can find them. Problems 5-2, 5-5, 5-9, and 5-11. I think that's it for today. So do those. That gives you some that are method of joints and one or two that is method of sections. Do those, and I'll post the solutions to those between now and say tomorrow night. Okay. If you don't see them, somebody send me an email, and then I'll post the videos of this up on Blackboard as well, or excuse me, on YouTube.